So in this video, we will see about Gale-Shapley algorithm, the main algorithm which we use in our project, and how we use this algorithm to build our project, which is the JEE allocation algorithm. So let's first see the statement of Gale-Shapley algorithm. It is always possible to form stable marriages from list of preferences. So let's understand what does this means by taking some examples. Suppose we have three boys B1, B2, B3, and we have three girls G1, G2, G3. Now suppose all these boys wanted to marry a girl and all these girls want to marry a boy, and suppose they have a preference order of the opposite gender, like the order in which they will prefer to be married. Suppose that boy 1 prefers G2 more than G1 and prefer G1 more than G3. Now suppose the boy B2 and boy B3 have some lists also, some preference list also. Let's suppose it is G1, G2, G3 and again G1, G2, G3. Now the beauty of this algorithm is that even if the preference list repeats, the algorithm will still be able to find a stable match. And suppose the order of preference of G1, G2, G3 is given as B2, B1, B3, B1, B2, B3, and again let's take B1, B2, B3. Now after the running of the algorithm, we will get the output which will look like this. Now I'm just writing a example, like it's not the obvious answer of the question which I have given here. Let's just to get an idea about how the output will look like. So we will get pairs. Suppose B1 get matched with G3, B2 gets matched with G2, and B3 gets matched with G1. Now, the most important things about these pairs will be that these will be stable pairs. The marriages happening will be stable. Now, what I mean by this, let's see in an example. Let's take the simplest case possible in which we have two pairs of two peoples, B1 and G1 and B2 and G2. Let's see how an unstable pair looks like. Now, suppose B1 likes G2 over G1, but here it is matched with G1. Now suppose G2 also prefers B1 more over than B2, but here she is matched with B2. Now B1 is liking G2 over G1 and G2 is liking B1 over B2. So these pairs are unstable. What will happen is that this boy B1 and this G2 will run away from their pairs and will form a new pair. So we have seen that these two pairs were not stable. So that's the explanation of Gale-Shapley's algorithm. So the algorithm is taking a O of n square time. So now what's the reason behind this? Now let's see how input is entered and what is n. Let's understand there. So the input to this algorithm, the code expects a 2n times n two-dimensional array where the first n rows are the preference list of boys and the next n rows are the preference list of girls. Now, so we have n rows of preference list of boy and n rows of preference list of girls, and there are n boys and n girls. Now for each, let's understand the time complexity here. Now each boy will have n girls in his preference list. Now what the algorithm does is that at each iteration the men will eliminate one woman from their list, and since there are total of n men, so this process will happen n square times. So in the worst case this process will happen n square times, so the complexity is of n square. Now how we are using this algorithm in our JEE seat classification. So you must be knowing that in G counseling there are some seats and there are some candidates, and all the candidates want to get a seat and they do the counseling and they get that. So to make our problem a little bit easier, we have taken some assumptions like number of let's make me the heading the G allocation system algorithm. So we have taken some assumption number of seats is equal to number of candidates, there is only one seat round of counseling, so now we are assuming the seats, let me write it here, we are assuming the seats to be women and the candidates to be men. Now the preference list of men will be the order in which they want the colleges. So how we have implemented this in algorithm is like this. We have 5 colleges in our algorithm, 1 2 3 4 5, and we have given the seats number as like this 50 51 52. These are the seats number and these are the colleges number. So like what happens is that whenever suppose a candidate, a man select uh, order of colleges like 2 3 4 5 1, so the his preference list will be internally generated as 60 61 and so on till 69 and then 70 and so on. So that's the preference list of seats which are women in our algorithm. And one obvious thing is preference list of women. Now we have also used the reservation part. I mean the concept of reservation is also there in our system. So the preference list of women, the seats will be a little different. Like in general, if there were no reservations, the preference list will look like this: 1 2 3 4 5 6 7. These are the general air all India ranks. But we have done everything. We have classified some the candidates into general, OBC, SC, ST, and we have categorized the seats, the each college's seat, into 4 categories. We have given 40% seats to general, 30% to OBC, 20% to SC, and 10% to ST. So like for general seats, this preference order will work. Like this will go till the 49th rank. Now for OBC seats, what we have to do is we first have to place the OBC students here in the starting of the array. And after the OBC students are finished, we have to place the remaining candidates in order of their general rank. So we have to like do sorting here and then merge these arrays. So we get a preference list for a OBC seat. So I think that's enough for the algorithm. Thank you.